Now for part B, what part B says is, it says use the solution you obtain to determine the limiting velocity. So what we're told to find is, we want to find the limit as t tends to infinity of v of t. We want to find this. Now to be able to find this, there is something you need to know. It's most likely you must have forgotten this, that the sign, when you say sine of x, or should I say when you say sine of t, what this means is e to the power t minus e to the power negative t all over 2. That's what it means. And when you say cosine of t, it means e to the power t plus e to the power negative t divided by 2. So when you say the tan of t, it means the sine of t all over the cosine of t. So when you divide this by this, you have e to the power t minus e to the power negative t divided by e to the power t plus e to the power negative t. So we could rewrite this, if I multiply both sides, that's both the top by e to the power negative t and this side by e to the power negative t. So what I'm going to get there is going to be, you have e to the power t times e to the power negative t becomes 1. That'll be 1 minus e to the power negative 2t divided by 1 plus e to the power negative 2t. Now this is the formula for tan of t. So, and then what we have here is, exactly what we have here is tan of, so what we have is root kg over mt. So I'm going to call this, you can just call this b. It's a constant, like say tan bt plus c1. So this is t, this is bt plus c1. So anywhere we see t, we're going to be putting bt plus c1 there. So this becomes 1 minus e into minus 2 into, so we have t here. So I'm going to replace it with bt plus c1. That'll be bt plus c1 divided by 1 plus e into negative, then b into t plus c1. Now we are told to find, you see what the question says, it says find the limit as t tends to infinity of v of t. So over v of t, that's of root mg over k tangent then root k g over mt plus c1. Now this here, when you take the limit as t tends to infinity of this, as the limit as t tends to infinity, you'd observe this is negative, so this goes to 0 and this also goes to 0, so this is going to give us 1. So it's like the limit as t tends to infinity sends this whole thing here to 1, so we'll be left with only root mg all over k, and that is going to be our final solution. This is going to be the limiting or the terminal velocity based on that. Now the last question says, if the distance, the relationship between the distance and the velocity is v of t, find an explicit expression for that using this initial condition here. Now, how do we go about this? Now we are told that, according to what we're given in the question, it says that, so I'm going to call that part C. It said ds dt equals v of t. So we want to find s. So this one implies that the s equals the integral of v of t dt. So that is that. So that implies that s equals the integral of v of t. So what did we get for our v of t initially? So we recall that this is our v of t here. Our v of t is root mg over this. This is our v of t here. So which is what we're going to integrate. And then we know that this is our c1. So instead of writing v of t now, so I'm going to be writing root mg root mg all over k fan of root kg all over m t plus c1. So where we know our c1, we know that c1 equals arctangent of v naught, because we know we had this here of v naught times root kmg root k all over mg. So many times I really like representing whenever I see constants clustered together here, it's best to represent it with a new constant to make the whole thing less, or make the whole calculation simpler. So I'm going to say let b equals this constant here. So that's going to be let b equals root mg all over k. So if b equals that, so what we have is like we are integrating s integral of b, the tangent of gt all over b plus c1 dt. So when we integrate this, now another thing you need to note is integrating the arctangent. So just to be sure you've not forgotten, is if you have the arctan of t dt is the same thing as the integral of the sine of t all over the cosine of t dt. And then since when you differentiate cosine of t, you have sine of t. So this is going to give you the ln of the cosine of t. So similarly, when you integrate the whole of this, now this tan, this is a constant. So this is just going to give us b squared all over g, the ln of the cosine gt all over b plus c1 plus an arbitrary, because we are integrating, so we should have another arbitrary constant, which is c2. But then we also told that s, we're given the initial condition that s, the distance at 0 is 0. So implementing that, so this is our s now. So this is when s is 0, t is 0. So when t is 0, this goes to 0. So we now have b squared all over g, the ln of the cosine of c1 plus c2. So, and our aim is, we already know what c1 is. This is the value of c1. So what we want to find is c2. So to find c2, we need to bring this one, we bring it to the other side here. So that means that c2 equals minus b squared all over g, ln of the cosine of c1. That's going to be, so therefore now we have already gotten the value of c2, and hence we now have our final solution as s to be equal to m all over k. You know, s is b squared all over g, and we already know what b is representing. That is b equals root m over g. So b squared is going to clear the mg, is going to clear the root sign. So we'll have m over k ln of the cosine root of kg all over mt plus c1 plus c2. So this covers here. So where c1 equals what we have here, that is the arc tangent v naught root k over mg and our c2 as C2 equals minus M all over K, the lane of the cosine of C of C1. And that completes the problem actually.